Welcome to Knowledge Suitcase. Today we dive into one of the most fascinating chapters in physics, resonance and interference phenomena. Let's explore how vibrations and waves behave, interact, and sometimes even amplify each other in the physical world. What is resonance? Imagine several pendulums hanging from a string. You pull one to the side and let it swing. Over time, others start to move too, but only those with the same length. That's resonance in action. When an object receives vibrations that match its own natural frequency, it begins to vibrate with increasing amplitude. This happens not just with pendulums, but also with air columns, musical instruments, and even buildings during earthquakes. Resonance in air columns. Have you ever blown across the top of a bottle and heard a musical note? That's because the air column inside resonates at a specific frequency. If your blowing matches this frequency, the sound is amplified. This is called sympathetic vibration. Whether it's a closed tube or an open tube, the length of the column determines its natural frequency. In a closed tube, sound reflects back without changing its phase at the closed end, but at the open end there is a phase change. This complex interaction of reflections builds up standing waves, and when the conditions are just right, you hear a strong, clear note. Now let's talk about interference. What happens when two sound waves meet? If they are in phase, their effects combine, a louder sound results. If they are out of phase, they cancel each other, leading to silence. This is the principle of interference. There is a cool device called the Herschel divided tube. It splits sound into two paths. If those paths differ by half a wavelength, they cancel each other, producing silence. But if they match, they reinforce each other, producing a loud note. This technique helps calculate the wavelength and velocity of a sound. What are beats? When two sounds with slightly different frequencies play together, they produce alternating loud and soft sounds called beats. Musicians use beats to tune instruments. Fewer beats means closer frequencies. When the frequencies match, the beats disappear. So, to summarize, resonance happens when frequencies match and vibrations grow stronger. Interference explains how sound waves combine constructively or destructively. Beats arise from slight frequency differences and help in tuning. From musical instruments to acoustic engineering, these phenomena shape our sound experience every day. If you enjoyed this video, give us a like. Subscribe to Knowledge Suitcase and hit the bell icon for more fascinating explanations. Thanks for watching and keep exploring the science around you.